Hello everyone, my name is Johan, and together with Anna, all right, carry on like nothing happened. So together with Anna, who kind of made this joint effort called Exploring Real-Time Visualizations to support chord learning with a large music collection. So where is this all coming from? We're both working on a research project called Audio Commons, and the idea behind it is that we try to promote Creative Commons audio. So we have industry partners that are focusing more on creative professionals, by which I mean using Creative Commons audio as background music for videos or for use it in games. But here we will present to you a web app that's in continuous development, and it's called Xambó. What's the idea behind it? We're trying to aim for end users, specifically music learners. We try to give them new and varied practice material, and at the same time, for the artists on Xambó, which is a Creative Commons music platform, we try to increase their exposure by suggesting their material to new users. And finally, the idea behind it is that it's instrument agnostic, so it doesn't matter what instrument you play, there should be something in there for you.
Yeah, so the kind of workflow that we envision with this web app is that the music learner connects to the app. It can be with any musical or melodic musical instrument. And so the music learner types the chords that she or he knows, or a selection of those. And then the web app retrieves a set of songs from a database, in this case, Xambó, that we will explain later. And then the music learner can play along the chords that she or he knows as the song plays. And also the user can get more information if she wants to going to the Xambó website.
Hopefully this will all make a bit more sense once we show it to you. So there's a companion website which you can revisit later on, but I'll try to get it out now. So this is what it currently looks like. So we have a query interface. We just want to select some chords. So if anyone would like to shout some chord names, or I pick them myself. Excuse me? E flat major. All right, E flat major, a bit more. I'll just do a random selection, see what comes out. So this is what it currently looks like. You get suggested a list of songs, which you then can play. Seems to be quite a slow start, so it will be a while before there will be any chord changes, I'm afraid. I didn't pick it. I had good tracks prepared. Anyway, let's not wait for it. You can go to the website, try them for yourself, but kind of the main focus of this paper is where we're looking at different visualization types. So I'll talk a bit more about that later. Basically, it's two, one linear, one circular, which we present to users. So how does it work? Since we need a large database of chord transcriptions, we obviously want to automate it. The sites we're targeting for is not really feasible to do by hand, and even if you would think about crowdsourcing it, searching it all for a website, you need to keep in mind that this is all Creative Commons audio, which means most people have never heard of it, so it's very unlikely that somewhere on the web somebody made a chord transcription. I'm not really going to talk about the algorithm behind it. It's been published previously, last year at Izmir, but one important part that is relevant for this talk is that it includes a confidence measure. So not only does it do the transcription, it also gives an indication of how well it thinks it did, and that is quite important in handling the erroneous output, because since it's all automatically, I can guarantee you there will be quite some errors that are being made, and the way we can handle that in this application then, just by hiding those songs of which we're not sure that the algorithmic output is decent. So if you then saw the query interface, you might have noticed there are 6 different chords that are able to select. So 5 types: major, minor, dominant 7th, major 7th and minor 7th. And the way it works, it's been approached as a classification problem, a strict classification problem, which means that at any given point in time is assigned one of those 60 labels, which is definitely one of the drawbacks at this point, because if you play a chord, or if there's a chord in the song that doesn't fit into one of those categories, it still will be shoehorned into one of them. Then finally, the data set. This is where the Jamendo in Jamendo comes from. So you might know that Jamendo is a music platform for Creative Commons audio. Any user can upload a song as long as they're willing to license it in Creative Commons. And there is a kind of lesser known aspect to it. You can also opt in to give Jamendo permission to license out your own song. It's then called a branch called Jamendo Licensing. And what they do, then try to offer your songs to, what I said, these content creators. But also, for instance, curate a radio station for instance, to play in shops as background music. So through that, Jamendo Licensing also offers an API which can use to download the audio, and they offer around 200,000 tracks, as you can see, but specifically for the cases where they offer the in-store radios, they do some light curation. It's not really based on artistic merit, but it's purely recording capacity, recording quality, because before you're going to play something in a store, you would expect it at least to be not clipped, to be not a joke track. And anyway, if you filter out all those number of tracks, you end up with approximately half of those 100,000 tracks, which we all analyzed with the previously mentioned algorithm. Then over to the architecture of the app we're going to present, specifically the backend. It's kind of a Chord database we built using the algorithm. It's a MongoDB database, and then once the query comes in, the algorithm tries to match the chords that are presented by the user with all the songs in the database. So just tries to find only songs that contain exactly the chords that are asked for. And the reason we're aiming for only giving songs that contain exactly the songs that are the chords that are being asked for is that one of the use cases might be that we have beginners that only know the specific chords they asked for. So in that case, it would be unacceptable to return songs that contain any additional chords. And then kind of the ranking of the results in this is the place where the confidence comes in really, and we only present those songs for which the algorithm is relatively sure that the output is correct.
Yeah, in terms of the front end, we are using an MVC approach. Basically, for the model, we have used Flask, which is a Python micro framework for web. And then we've been also using Bootstrap for the visual part and JavaScript jQuery for the control part. And so we deal with both the queries from the user, but then we also do asynchronous calls to Jamendo and get back the media files.
So as you could see in the short demo, there are two types of visualizations we're trying out. One a bit more linear, based on time axis, just the current chord is being played in black, and then the next upcoming chord in gray. So just moving along from right to left, like you would expect. And then to find something else, we tried a circular approach where each chord has a fixed position in the circle, in the chromatic circle, and then it will light up whenever it's being played.
So yeah, we've been doing some user studies, two at the moment. One we presented at Audio mostly with 7 users, and this is the second round with 7 more users. And so we wanted to compare the two visualizations, whilst in the previous evaluation we wanted to evaluate the query space. So in here we wanted to compare, so we asked the users to bring their music instruments, or they could also get connected from their room or other spaces if they want to, and they were able to, or they were asked to do this task 3 times and rate whether they would have any preference between the two visualizations. And so we gathered 7 participants, 4 women, 3 men, between 26 and 43 years old. 3 remotely were connected, the others collocated, and we obtained 21 independent trials. As you can see, there were different instruments that they chose. Yeah. And we will see now a video of the experience from the user perspective. Yeah. We've seen this query already. So yeah, as you can see in both visualizations, we were just showing present chord and future chord. The difference was with the color and the position, and the size as well. Is it volume? So in terms of the results, we obtain, as you will see now, a stronger preference for the linear visualization, and circular was, some of them prefer it, but not strongly. And in terms of chords.
So then we can have a look at what people are actually asking for. We see a strong preference for major and minor chords. So this plot shows you of the queries, the percentage of the time these chords were asked for. So in 57% of the queries there was a minor, and 57% of the queries as well a C major. So we see this preference for major and minor chords, and also the kind of the natural note names without any accidentals. And on average, there were 7 chords asked for each query.
Yeah, in comparison with the plot we saw before, but also from the talking alouds given by the users, we found that there were some preferences for both, actually. Basically, there are some quotes given here. You can see more on the paper, but the linear visualization was associated with more simplicity. The circular visualization instead was associated with more complexity. The color was appealing, but also we were suggested to use it more meaningfully. So here we were using it kind of randomly. Yeah. Also, we obtained design issues and suggestions from users, mainly about the chord recognition and transcription, that we could anticipate a little bit more the information, and also that the activity could be more adapted to the music education practice. And we had some suggestions about giving more information, structural information about the song, and also provide some hints. We also had like this finding in the previous study, providing more hints during the query, so some suggestions depending on the database. Oh, yeah. And as lessons learned, basically, oops, sorry, it looks a promising app. It should blend better, though, with the real activity, the musical practice. We need to improve the user experience as well. Keeping the two visualizations, we found it's interesting because it depends on the user, but also on the particular task. And yeah, the idea is to keep improving and support real scenarios.
So future work-wise, a couple of points you've already seen. I can tell you that based on all the feedback we gathered, there will be a next iteration which will be developed by a professional web company, so which will have a bit more a flashy interface and a bit more bells and whistles. Then in terms of the Chord presentation, it would be nice if there is some contextual metric structure. So for instance, indicating the bar lines would be quite helpful. Then going back to the query screen, it would also be nice if you have some more guided exploration for the users, where once you select a chord, it will indicate which other chords are likely to go well with it, so that you end up with nicely sounding songs. And then finally, we also would like to see how this will work in an educational context, specifically focusing on beginners. And then it's now called Jam with Jamendo, but it would be obviously great if we could use at one point other data sets, maybe even commercial music.
Yeah, we would like to also mention that other uses that we found is improvising on top of the application. Maybe we can show a very short video snippet, or there's time? No time? Okay, yeah. So we move on then.
Then I'll just have to say, this is again the URL for the companion website. If you want to check out the video again or the interactive demo, this is the place to go. Thanks.
All right. There are a lot of questions, so we'll hop right into it. Two of them I can combine together. The first is the Jamendo song data available, and what size is the Jamendo data set? How big is it?
So the audio database is, well, the API offers 200,000. Since we are in touch with Jamendo, they're also a project partner. We selected 100,000 of them, which they basically said these are the ones we use for our install radio. So if you use the other half, it's more at your own risk. You might encounter very strange things or not so nice things.
Another one is, why the limitation of 5 chord qualities? There you go.
Pick one, yeah.
You got to have limitations. Let's see, and then another is based on the visualization, and maybe this is something you're going to explore. It seems like that. But why are the major chords placed in the middle and thus the smallest? And also, why choose the larger and smaller font size instead of a different color tied into that?
Yeah, this really was our first approach. We wanted to show like this circular visualization and yeah, exploring, not really giving meaning to the colors yet, but there's obviously room for improvement about the relationship between the chords, where to position them. So this is really just a first initial sketch. So.
I have one more. We'll have to keep it short, but how did you start this project? Is it just an experiment, or did you find out that people want to learn songs this way by choosing the chords first?
It's an experiment. Hopefully somebody likes it.
All right. I think that covers most of them. The other ones were about colors and the 5 chord qualities. I have one more. Have you thought about other representations that would also reflect the chord's duration?
Yeah, well, from the feedback, we really need to show more contextual information, so probably that implies adding more visualization or graphics. Yeah.
All right, thank you.